Hello. Technical depth in the peer review documentation of R packages and rOpenSci case study is a study conducted by myself, Sadia Kudabaks from the University of Saskatchewan, Melina Viduni from RMIT, and Fatima Fard from the University of British Columbia. The goal of this study is to investigate technical depth in R packages that are submitted for peer review to rOpenSci before being published. rOpenSci is an organization that organizes and reviews R packages. We extracted two random samples of comments of size 100 and 358 after some filtering. The comments are lengthy and were broken down into what we call phrases. We classified the comments according to 17 different types of technical depth from the literature. We first classified 100 comments as part of the learning process and came up with an initial taxonomy of 10 types of depth. Then we classified 358 comments using the taxonomy of 10 types of depth. We also extracted the unique user role. The goal of the first research question is to determine the different types of technical depth as reported by different user roles. By different user roles, we mean authors, reviewers, and editors. We came up with three perspectives, the user, developer, and CRAN, to group the 10 types of technical depth based on who is the most affected by each type of depth. We found that the user is mostly concerned with usability, documentation, and requirement depth. These depths ultimately affect mostly the user of the packages rather than the developers. We found that the developers are mostly concerned with code, design, test, and defect depth. We also found that defect tends to be introduced as a result of the other three types of depth. CRAN, being the official venue to submit user-generated R packages, perform automated checks on package size, structure, and versioning, among others, when a package is uploaded. The goal of research question 2 is to determine the distribution of the different types of technical depth and analyze which depth is the most and least prevalent. We found that documentation depth makes up about 30% of all depth instances, followed by code depth, which is 15%, and design and defect depth, which is 12% each. Versioning depth was the least reported type of depth. The goal of research question 3 is to investigate the association between user role and depth types and understand the differences among the user role in terms of the technical depth type they report. We found that depth type and the user role are independent and that reviewers report more depth than other user roles. However, the type of technical depth encountered by each user role is different. Reviewers focused on documentation, code, design depth more than others. Authors focus mostly on defect, test, and architecture depth, and the editors pay more attention to documentation, defect, and requirement depth. Lastly, are the implications of potential implications of our research. Documentation depth is the most common but one of the least studied type of depth. This reinforces the need for documentation depth to be studied more extensively and to determine what constitutes good documentation so that we can investigate ways to manage it. We provide a taxonomy for R. Since technical depth in R is understudied, this provides opportunities for replication, or it can be used as a starting point in other scientific software to augment our taxonomy. There's also an opportunity to further investigate why reviewers are focused on documentation and authors on the package structure. The R community can use this study to create new package authors training to increase awareness of technical depth. They can also use this taxonomy for detecting specific smells specific to R. An organization like rOpenSci can include checks pertaining to technical depth in their peer review process by modifying the submission templates to include checks based on our findings. Thank you.